Patras naman sa'yo. Patras dyan din ako.
Okay, good morning. Our lesson for today is all about functions and relations. Okay, so when you say functions and relations, so what comes in your mind? Okay, so when you see on the picture, so we have here a passport, right? And we have here one person. Isn't it? Each one person has a unique passport. Okay, so there's a relationship between the passport and the person that's holding it. Okay, so when we say relations, we are talking about pairs. So we have the pairs. For example, we have the ordered pairs. As in it, in the Cartesian coordinate plane, we have the ordered pairs. We have x and y. That's like, for example, we have the ordered pairs 0, 2. Using the Cartesian coordinate plane, we can locate the 0 and 2. So this is our x-axis and this is our y-axis. So therefore, if we have here the ordered pairs 0, 2, so this will be our x and this will be our y. 0 is our x, the first coordinate, and y will be our 2 will be our y coordinates. Okay, so for today, so we are going to discuss what would be the relations. So again, when we say relation, it is any set of input and output values. There is a pair. And we have here domain and range. So when we say domain, it is any relation. It is a set of inputs called x coordinate of the ordered pairs, while the range is any relation and it is called outputs. Okay, we have 4 ways on how to represent relation. The first one is using ordered pairs. The one that I give example, we have 0, 2. Next one, we have the mapping diagram. We are going to make a mapping diagram. And the third one, we have table of values. And the fourth one, we have graph. So this, again, the 4 ways to represent relation are ordered pairs, mapping diagram, table of values, and graph. Okay. So this is the representation of relations. On the first example, we have here ordered pairs. We have 1, 2, -2, 4, 0, and -3. And the other way is using graph, using our Cartesian coordinate plane. So we have here the representation of our relation. And the third one, we have mapping diagram. So on the first diagram, we have here the domain. It is the first set of coordinates. And on the second one, we have the range. We have the second set of coordinates. So we can map from the domain going to range. So that would be our relation. So for example, here we have 1 corresponds to 2, -2 corresponds to 4, 0 corresponds to -3. So there is 1-to-1 correspondence between the coordinates or the pairs that we have. So that is relations. We also have here functions. So when we say function, it is a relation. It is a relation in which every input is paired with exactly one output value. Again, it is paired with exactly one output value. So for example, we have here 0, 1, 2 on our input. We also have on our output, we have 3, 4, 5. So we can say that it is a function if each input or domain is paired exactly with one coordinate on the output. Okay? So when we say function, it is paired exactly with one coordinates. Okay? Just like for example in this illustration, so we have here the functions. We have one-to-one correspondence. Each input corresponds to output, one output. Okay? So we also have many to one. It means that our domain corresponds to output, so it can be many to one. So for example, we have here, we have 0, 2, we have 0, 2, 0, we have 3, 0. So if we are going to look at this ordered pairs, we have 0, 2, 2, 0, 3, 0. So we have what we call domain. When we say domain, it is the set of the first coordinates. So here, our domain would be the element in the x-axis, or the x. We have 0, 2, 3. So this would be our domain, 0, 2, 3. And our range here is the y coordinates. So we have 2, 0, 0. When we say functions, so we should have a unique domain. So there should not be repeating numbers in our domain. So as you can see, we have 0, 2, 3 as our domain. Therefore, this set of ordered pairs is an example of functions. Okay? Again, when we say domain, this is the x, or the input. The first set of coordinates, while the range is the y, or the second, or it can be the output. This is the second set of coordinates. So in this illustration, we have 0, 1, 2 as our input. So this will be our domain. And this output, we have 3, 4, 5. This will be our range. Okay. Okay, so how can we identify if the graph is a function? Okay, we can use the vertical line test to determine if the relation is function, because not all relation is a function, but all functions are relations. So take a look on this example. We have here a graph. We have here the x-axis and the y-axis. So as you can see, we have here a straight line for the graph. So to identify if this graph, we have here, so we are going to use the vertical line to determine if our graph is a functions. But this graph is a relations, because we can have, for example, we can have here, we can locate this point as -1, 1. So we can have a pair. So this is an example of a relations. So how are we going to know if this is a function? By just using the vertical line test. So if it touches only once using our vertical line, this one, so it only touches, so therefore this is an example of function. On the other hand, if we have here another example, let us identify if this graph is an example of functions. By using vertical line test, as you can see, so we have here this point, and this point touches the vertical line. This point also, this point, so we have here two lines that touches together. So therefore this graph, curve 1, is not an example of functions. So this is not a function. Okay? Again, when we say functions, it is paired exactly with one element in the mapping diagram. So the first set of elements should be only ones. Okay? We have 0, it should be corresponds to other element on our output. Okay? And when you say relation, there is a pair for that. Okay? So using ordered pairs, the first element would be our domain, and the second element would be our range. And that's all for today.